A 2,000 kilogram log with a volume of 4 cubic meters is held at the bottom of a freshwater lake. And in part A, it wants to know how much force is required to hold the log down. So I'm going to start by drawing a free body diagram for the log. The dot represents the log, and the forces acting on the log are the gravitational force, Fg, the buoyant force, because it's underwater, and because this object wants to naturally rise to the surface, you have to apply a force to hold it down. So I'm going to have another downward force, and we'll just call it because I'll call it Fp for like the pushing force, just whatever you want to call it to hold it down. So to hold it down in place, that is Newton's first law, net force in the y direction is equal to 0, which means the buoyant force, the upward force, is equal to the two downward forces added together, the pushing force plus the gravitational force. And I want to get the Fp by itself, so I'm just going to bring the Fg over to the other side. So the pushing force is equal to the buoyant force minus the gravitational force. The buoyant force, the formula is the density of the fluid times the volume of the object times g minus the gravitational force, which is the mass of the object times g. This is equal to the density of the fluid. It's a freshwater lake, so that's a density of 1,000, times the volume of the object, which is given as 4, times g, which is 9.8, minus the mass of the object, that's 2,000 kilograms, times 9.8, and all of that is equal to 19,600 newtons. So a lot of force in order to be able to hold the log fully submerged. For part B, what is the acceleration immediately after it's released? So we know that the log is going to start accelerating upward, so we can just use Newton's second law. A is equal to the net force over the mass. And in this case, we can say that the force, once it's released, is just going to be the net force, which is the equivalent of the pushing force to hold it down. So 19,600 divided by the mass of the log, which is 2,000. When you divide 19,600 by 2,000, you get 9.8 meters per second squared. Is it a coincidence that the acceleration of the log happens to be the exact same acceleration as Earth's gravitation? And the answer is yes. It is just a pure coincidence. And notice this is a positive acceleration, which means it is accelerating upward. If it was a negative acceleration, it would be going downward. And for part C, what percent of the log is submerged once it comes to rest at the surface? Well, the percent submersion, or the fraction that's submerged, is basically just the density of the object divided by the density of the fluid. The density of the object is not given, but you can figure it out by doing the mass of the object divided by the volume of the object. All that is divided by the density of the fluid. So the mass and volume of the object were 2,000 divided by 4. All that is over the density of water, which is 1,000. 2,000 divided by 4 is 500 over 1,000, which is 0.5, or exactly 50%. So that means the log is exactly half the volume of the log is submerged and half the volume is above the surface.